and welcome to WingTips. This is the second video in our series that delves further into the WingtraCLOUD platform. Our previous video covered the structure of the platform and highlighted how it is better assisting companies in keeping their entire aerial data collection workflow more organized. Today, we're going to take it a step further and show you how WingtraCLOUD enables large area flight planning. How large, you ask? Approximately 5,400 acres. As you can imagine, a project of this size has many moving pieces, including multiple days of flight, battery swaps, and takeoff areas. This project also presents a unique operational environment with challenging terrain spanning over a village. With a project this size, we must ask ourselves, how do we structure it so that we're not only maximizing safety, but also operational efficiency? So let's get into it. Jumping into WingtraCLOUD, you can see that we have planned several days of missions, including the pilot assignments, and we'll be using our Map 61 payload. As planned, the first day of flight missions happen in the northern section of the site. The day's missions span over 3 areas, involving nearly 3 hours of flight time. We'll also have to do 5 battery swaps, where the Wingtra lands back at its takeoff point, then continues from its last data collection point. From an overall project management perspective, what's really nice here is that you can see how the separate flight days come together by toggling on or off the additional flights of the site. Additionally, everything on the map marked with an F represents a separate flight plan, and you can monitor the status of each flight. This serves as a valuable reference point as the project progresses through the various stages from planning through data processing. What's also important to understand is that we now have a context in which we can easily see that there is sufficient overlap between the adjoining flight areas. This gives us the confidence that there will be no data collection gaps when this entire project is processed and stitched together. Let's now discuss how we maintain safe flight operations. From this standpoint, having the ability to colorize by visual line of sight enables us to observe from our takeoff and landing point that we will maintain full visibility of our aircraft. Moreover, the 3D tools allow us to get below the flight lines to further inspect the area. With buildings also being indicated in 3D, we're confident that no protruding ground-based obstructions exist that could interfere with our flights. Now let's discuss flight optimization with the use of some of our other visualization tools. We're now on day 3 of the flights. By colorizing based on the ground sampling distance, we can expect GSD variations along our flight lines. As you can see, our GSD is quite good. As we switch back to the 3D view, we can see what, in part, has helped us obtain such a good GSD. This flight plan takes the terrain into consideration, and we are flying parallel to the contour of our landscape. All in all, this is a great example of what an optimized flight plan looks like in challenging terrain. Now, there's one final point that I'd like to cover for today, and that is that flight planning doesn't have to live in a vacuum. Collaborative tools allow for annotations and the sharing of resources, encouraging communication and bridging the gaps between project managers, planners, and those in the field collecting the aerial data. Well, that's it for today. I hope you have found this video informative, and we'll see you next time for more wing tips.